Imagine, if you will, a time shrouded in smoke and mystery. In dimly lit workshops, figures hunched over bubbling concoctions and strange-smelling furnaces. These were the alchemists. They weren't just simple craftsmen, philosophers, mystics, dreamers, all rolled into one. Their world was a curious blend of spirituality and early fumbling science. The goals they chased were nothing short of legendary, the kind of things you read about in fairy tales. They sought to unlock the deepest secrets of the universe, to understand the very fabric of existence itself. It was a quest born from a deeply human desire to control nature and to transcend our own limitations. The alchemists pursued two grand, almost impossibly ambitious prizes. The first was the Philosopher's Stone. This wasn't just any old rock, a legendary substance said to possess miraculous powers, chief among them, the ability to perform transmutation, specifically turning common, worthless metals like lead into pure, gleaming gold. For centuries, this was the ultimate obsession. The second great prize was the elixir of life. The long, slow transition from alchemy to what we would recognize as chemistry was not a single event. It was more like the sun rising very, very slowly over a misty landscape. For centuries, the line between mystical belief and practical experimentation was incredibly blurry. An alchemist might spend the morning consulting astrological charts and the afternoon meticulously recording the weight and color changes of a substance he was heating. The spiritual and the physical were seen as two sides of the same coin. The purification of metals was often seen as a metaphor for the purification of the alchemist's own soul. This change began to accelerate as a new kind of thinking started to take hold. People grew a bit more skeptical. They started to question the ancient texts that had been treated as infallible truth for generations. Instead of simply trying to replicate a secret recipe for gold, some practitioners began to ask more fundamental questions. What is this substance really? What happens when I mix it with that one? Why does it change color when I heat it? This shift in focus from achieving a magical outcome to simply understanding a process was monumental. The laboratory, once a place of secret rituals, was slowly becoming a place of systematic inquiry. The tools of the trade began to evolve as well, though it was a messy and often dangerous process. Alchemists were relentless inventors of laboratory apparatus. Among the many shadowy figures hunched over their crucibles, a few names shine brightly through the smoke of history. One of the most important was a man who went by the name of Jabir ibn Hayyan, known in the West as Geber. Living in the 8th century, he is often called the father of alchemy, and by some the father of chemistry. He was incredibly systematic for his time. He insisted on the importance of practical experimentation and meticulous documentation. Jabir is credited with discovering and describing many crucial chemical processes, including crystallization, calcination, and most importantly, distillation. He used it to purify substances and isolate powerful acids like nitric acid, sulfuric acid. Centuries later, a bombastic and brilliant figure named Paracelsus stormed onto the scene in Europe. Born Theophrastus von Hohenheim, he gave himself the name Paracelsus, meaning beyond Celsus. He was arrogant, traveled widely, and publicly burned the books of traditional medical authorities. Paracelsus championed the idea that the purpose of alchemy was not to make gold, but to make medicine. He argued that the body was a chemical system, and that illness was the result of chemical imbalances. He pioneered the use of specific chemical compounds like those containing mercury and antimony to treat diseases like syphilis. He was often wrong, and his remedies were sometimes toxic, but his core idea was revolutionary. Then came Robert Boyle, a 17th-century Irish aristocrat who truly stands on the cusp between alchemy and modern chemistry. Boyle was still deeply interested in transmutation, and spent a great deal of time and money trying to turn base metals into gold. He was, in many ways, still an alchemist at heart. Yet he was also a fierce advocate for a new, more rigorous approach to science. In his groundbreaking book, The Skeptical Chemist, published in 1661, he attacked the old alchemical theories of 4 elements and 3 principles. He argued that an element was a substance that could not be broken down into anything simpler, a definition remarkably close to our modern one. Boyle's greatest contribution was his insistence on method. He believed that experiments should be conducted carefully, recorded in painstaking detail, and most importantly, published so that others could witness and replicate them. This was a radical departure from the secretive world of the alchemists. He is most famous for Boyle's law, which describes the relationship between the pressure and volume of a gas. By performing careful measurements with an air pump, he demonstrated a clear mathematical relationship in nature. This was the new science in action, not mystical recipes but repeatable experiments and universal laws. He helped drag chemistry, kicking and screaming, out of the darkness of alchemy. The history of science is filled with people being wrong. And that's a wonderful thing. The alchemists were wrong about almost everything on a theoretical level. They were wrong about the philosopher's stone, wrong about the elixir of life, and spectacularly wrong about the fundamental nature of matter. But in their stubborn, centuries-long quest to prove their incorrect ideas, they stumbled upon an astonishing number of correct facts. Their mistakes weren't failures. They were incredibly productive detours. They were like explorers searching for a mythical city of gold, who, while they never found it, ended up mapping the entire continent along the way. Consider the tireless search for the philosopher's stone. In pursuit of this magical substance, alchemists mixed, heated, and distilled virtually everything they could get their hands on. They combined minerals with plant extracts, animal parts with metals, and subjected them to all manner of strange processes. In doing so, they accidentally discovered a whole host of new chemical compounds and elements. They learned how to make gunpowder more stable, how to create vibrant new pigments for artists, and how to prepare potent acids that could dissolve metals. None of these was the fabled stone, but in many ways they were far more useful to the world. One of the most famous happy accidents in the history of alchemy comes from a German named Hennig Brand in 1669. Brand was convinced he could extract gold from, of all things, human urine. His reasoning was that urine had a golden color, so it must contain some essence of gold. He collected vast quantities of it, rumor has it over 1,500 gallons, and let it putrefy for weeks before boiling it down to a thick paste. He then heated this foul residue to an extremely high temperature. He didn't get gold. Instead, he found a waxy white substance that glowed in the dark, phosphorus. For all their practical discoveries, the alchemists lacked one crucial ingredient, a reliable system for figuring out what was true. Their world was a jumble of observation, superstition, wishful thinking. A successful experiment might be attributed to a lucky alignment of the planets just as easily as to the ingredients used. This all began to change with the gradual development of something we now call the scientific method. This wasn't invented by one person overnight. It was a new way of thinking that evolved over time, championed by thinkers like Francis Bacon, Galileo Galilei, and later Robert Boyle. It was a recipe for discovery itself. The first step in this new recipe was systematic observation and the formation of a hypothesis. Instead of starting with an ancient mystical belief, you started by looking at the world. You notice something interesting, perhaps that wood burns but rock does not. You then make an educated guess or hypothesis to explain it. For example, perhaps wood contains a special substance that allows it to burn. This was a huge shift. The explanation had to be based on the physical world, not on a story about gods or magic. It had to be a testable idea, not a matter of faith. The next and most important step was experimentation. The experiment had to be designed specifically to test the hypothesis. If your hypothesis is that wood contains a flammable substance, you design an experiment to try and isolate it. You would need to carefully control the conditions, the amount of wood, the temperature, the air supply. And you would meticulously record everything. Every measurement, every change in color, every puff of smoke. The goal was no longer just to make something happen, but to understand precisely why and how it happened. This demand for controlled, repeatable experiments was a game changer. Finally, there was the analysis of results and the sharing of knowledge. This created a community of scientists who could check each other's work, replicate experiments, and build upon previous discoveries. This open, collaborative, and self-correcting process was the engine that would drive the incredible explosion of knowledge in the centuries to come. While big names like Boyle, Paracelsus rightly get a lot of attention, the story of chemistry's birth is filled with countless unsung heroes. Many of these were artisans and craftspeople who, through generations of trial and error, perfected chemical processes without ever thinking of themselves as scientists. Consider the glassmakers of Venice. For centuries they were the undisputed masters of their craft. To create their famously clear and vibrantly colored glass, they had to develop an incredibly precise, intuitive understanding of chemistry. They knew exactly which mineral oxides to add to create a brilliant ruby-red, deep cobalt blue, a secret so valuable that their movements were restricted by the state. There were also the miners and metallurgists. People like Georgius Agricola, a 16th-century German scholar, spent his life meticulously documenting the practices of miners. In his book De Re Metallica, he described in exhaustive detail how to find ores, extract metals, and refine them. This wasn't alchemy, it was industrial chemistry in its infancy. These were the people who figured out how to get purer iron for stronger tools, or how to separate silver from lead ore. Their work was practical, dirty, and dangerous, but it provided the raw materials and foundational knowledge. And we absolutely cannot forget the women who contributed to this story, whose roles have often been overlooked. The very first alchemist whose name we know from history was a woman, Mary the Jewess, who lived sometime in the first few centuries AD. She is credited with inventing several key pieces of chemical apparatus. Most famously, she invented a type of double boiler for gentle heating, a device still known in kitchens today as the bain-marie, which is French for Mary's bath. Throughout history, many women practiced alchemy, often in the context of preparing herbal remedies and medicines, but their work was rarely recorded or credited in the male-dominated world of formal scholarship. The transformation from alchemy to chemistry was not just a change in methods, it was a fundamental change in our relationship with the world. Alchemy was a whisper, a secret conversation with nature, language of symbols, language of spirits. It was rooted in the hope with the right words, the right rituals, the universe might bend to our will. Modern science, born from this mystical tradition, became something else entirely. It became a roar. It was loud. It was confident. It was a public declaration that the universe was not governed by whims, not governed by spirits, but by consistent, discoverable laws available for everyone to understand. The legacy of the alchemists is therefore a beautifully ironic one. In their secretive and often misguided search for impossible things like eternal life, infinite gold, they gave the world something far more valuable. They gave us the beakers, they gave us the stills, they gave us the furnaces. They gave us a massive, if disorganized, catalog of chemical reactions, and most importantly, they fostered a spirit of relentless hands-on curiosity. They showed that by mixing, heating, observing, you could learn new things about the world. They just didn't have the right framework to make sense of what they were seeing. The arrival of the scientific method provided that framework. It was like giving a powerful lens to someone who had only ever seen a blurry world. Suddenly, patterns emerged from the chaos. Antoine Lavoisier, in the late 18th century, used precise measurements to show that matter is conserved in chemical reactions, finally killing the idea of transmutation, earning the title Father of Modern Chemistry. John Dalton later proposed that all matter was made of atoms, giving a solid theoretical foundation to what the alchemists had only fumbled with. Chemistry became a predictive science capable of creating new materials, medicines, technologies on purpose, not just by accident. Today, every time a doctor prescribes a life-saving drug, every time an engineer develops a new lightweight material for a plane, every time we switch on a device powered by an advanced battery, we are enjoying the fruits of this incredible transformation. The world we live in is built on the foundations of modern chemistry.